Thanks for checking in. IATA Microbiology has over 35 years experience in the detection and control of microbiological growth, or MBG, in industrial systems, particularly fuel systems. I'm going to talk to you today about how to use our Microbe Monitor 2 test to detect MBG in aviation fuel systems. I'll talk about how to do this for aircraft fuel tanks and also for storage tanks and infrastructure in the aviation fuel supply chain. This training session is based on online animation videos which are available from our website www.echamicrobiology.com. If you have water in a fuel tank, there is a risk of microbiological growth. The rate and extent of growth will depend on the amount of water present and on other factors, particularly temperature. Active microbial growth can occur wherever there is free water in a fuel tank. This may be in pockets of water on the tank bottom, particularly at tank low points, but growth can also occur in films of water condensation on tank surfaces. With agitation and turbulence in the tank, microbial material is disturbed up into the fuel. Common fuel contaminants like fungi produce spores which are repelled from the water and dispersed into the fuel, spreading and colonizing any new areas of the tank where water is present. It is important to consider this uneven dispersion of microbes in the fuel tank. For a start, there will inevitably be some variation in test results obtained for different samples of the same tank. Samples of water will contain many more microbes than samples of fuel. Collecting samples with water gives the best chance of early detection of any microbial growth that is occurring. However, it's not always possible to recover water in samples, and so we believe it is very important that the test method used is able to detect the microbes and spores dispersed in the fuel, as these may be the only indication that a problem is present. Of course, regular draining of tanks to remove water is the single most important measure that you can take to prevent microbial growth. If you can't effectively control the amount of water in a fuel tank, this is what can happen. Microbial slimes develop which clog filters and foul gauges and can eventually cause corrosion. Unfortunately, all this happens inside the tank, and the only absolutely sure way to know whether it is happening is to enter the tank and inspect it, but that's not practical on a regular basis. You can take samples and you can look at them, but if you have a sample that looks like this one on the right, well, you already have a very severe problem. Significant levels of contamination are not always visible. Ideally, what we want to do is to take samples and test them with a sensitive test that tells us we have a developing problem before it becomes an operational issue. It's important to emphasize the need for a consistent sampling procedure. When sampling aircraft fuel tanks, try to maximize the chance of recovering water. Sample after the aircraft has been standing to allow frozen water to thaw and to allow water to collect at a low point. Don't flush away any water present before taking the sample. Sample the very first fluid that comes from the drain point. Taking about 1 litre of sample will maximize the chances of recovering water. Ideally, each drain point on each tank should be sampled. The frequency of sampling will depend on the risk of MBG. So consult the manufacturer's manual or AMM for specific sampling procedure details for your aircraft. So what about fuel storage tanks and filter vessels? Well, again, the best chance of detecting microbial growth will be to take samples from the bottom, usually from drain points. However, because these are drained very frequently in most fuel supply facilities, it may actually be very difficult to recover water. So often, in a routine monitoring program, it will be better to regularly test fuel phase samples from the bottom of the tank to ensure consistency. Samples should be taken immediately before any routine daily dewatering procedures. But you do need to flush the contents in the drain line leading to the sampling point first, before taking the sample. We want a sample of what's actually in the tank or filter vessel, not what's in the drain line. So here is the Micromonitor 2 test. It comes in pack sizes of 5 tests, and we also do bulk boxes of 50 tests. The test is published as standard industry method IP613 and ASTM equivalent D7978. Each test consists of a glass bottle containing a special gel that grows microbes and a syringe which is used to dispense fuel or water sample from the sample container into the Micromonitor 2 test bottle. Before starting the test procedure, remove and discard the plastic seal on the cap of the Micromonitor 2 test bottle. It also helps to loosen the cap of the bottle ready for the test. Samples should always be tested as soon as possible after they have been taken. Ideally, this should be within 4 hours, although that isn't always practical. But preferably, they must be tested within 24 hours. Any longer than this, and microbes in the samples may start to die off, and the test may underestimate the level of contamination present. Once you are ready to test the sample, shake it for 30 seconds to evenly disperse any microbial contamination present and mix up the water and fuel. Then, allow it to stand for 12 minutes so that any water settles back to the bottom of the sample. Observe the sample to see if water is present. If water is present, it is recommended that it is always tested with the Micromonitor 2 test. It will provide the worst case indication of contamination, in other words, the earliest indication of contamination. However, when no water is present, the fuel should be tested. As mentioned previously, if water is rarely recovered from a tank when sampling routinely, then it is recommended that fuel is always tested to enable more consistent trend monitoring. With the Micromonitor 2 test, the procedures for testing water and for testing fuel are slightly different. When testing water, the syringe should be used to remove water from the bottom of the sample container. It may be necessary to decant off some of the fuel first, or to transfer the water from the sample to a separate clean container to enable it to be removed more easily. When testing fuel, the syringe should be used to remove fuel directly from the sample container from a depth of about 3 centimeters below the surface. Avoid touching any parts of the syringe which come into contact with the sample or with the Micromonitor 2 test. It's best to wear disposable gloves. For water, it is recommended that 0.1 milliliters is tested. For fuel, it is recommended that 0.5 milliliters is tested. To get the correct volume, draw up slightly more sample than is needed into the syringe and then just press the syringe plunger so that the end aligns with the appropriate graduation mark on the side of the syringe barrel. Note you should use each syringe only once and then discard it. Remove the cap from the Micromonitor 2 bottle and place it on a clean surface. Dispense the contents of the syringe into the Micromonitor 2 test bottle by depressing the plunger. From now on, the procedure is the same, whether you are testing fuel or water. Place the cap back on the Micromonitor 2 test bottle, tighten it, and then tap the bottle firmly to break up the gel. Shake the gel thoroughly for 30 seconds to disperse the sample. After shaking, the gel should have an even, viscous liquid consistency. Flick the bottle to make the gel go to the bottom of the test bottle, and then tap it on your hand to form a flat layer of gel. Don't worry about air bubbles in the gel. The shaking procedure can be made easier using benchtop rubber bumpers, which we can supply separately. So here is the test bottle after shaking and tapping the bottle to create a flat layer of gel containing the dispersed sample. Over time, the gel will re-solidify, but it is now ready to incubate. When moving the test bottle, avoid excessive agitation and keep the bottle in a horizontal position. The Micromonitor 2 test should be incubated in a warm, dark place. It can be conveniently incubated in the box that the test is supplied in, for example, by placing this in a warm drawer or cupboard in a room where the temperature is relatively consistent. The ideal incubation temperature is 22 to 28 degrees centigrade, but occasional small fluctuations outside this range do not affect the test performance. If testing samples from tanks in warmer climates, then higher ambient temperatures can be used, as these will reflect the growth preference of any microbes present. However, we do not recommend incubating the test above 40 degrees centigrade. That's 104 degrees Fahrenheit. If it is not possible to find a suitable incubation location with a reasonably consistent temperature, then we can supply small incubators which help optimize the test performance. A larger incubator may be appropriate where a user is performing a large number of tests. The Micromonitor 2 test produces results of colony forming units, or CFU, which is a standard measure of microbiological contamination used in a wide variety of industries. As the test is incubated, each microbe uses the nutrients in the gel and the nutrients from the fuel sample itself to grow and multiply until a visible spot is formed. This spot is known as a colony, and each colony is derived from a single microbial cell, spore, or aggregate of microbial cells. Typically, the important microbes found in fuel systems take up to 4 days to produce visible colonies. Generally, the more microbes there are, the quicker the colonies become visible. The different types of microbes found in fuel can produce colonies with different size and appearance. It is the number of colonies which develop, which is important. This can be counted or estimated and converted to numbers of CFU per litre of fuel or numbers of CFU per milliliter of water, depending on which type of sample was tested. Here we see the incubation of Micromonitor 2 tests which have been used to test water samples. After 1 day, if a heavy contamination is present, as shown on the right, you may be able to see colonies already. You don't need to look at the test every day, but we do recommend examining the test on several days up to 4 days. After this time, the final result can be read. If you can already see that you have a heavy contamination after just 1 or 2 days, then there is no need to incubate the test further. When testing water samples, because there are many more microbes present than in fuel, it is usually not possible to count the individual colonies in the Micromonitor 2 test gel. However, the numbers can be estimated by comparing to a colour chart provided with the test instructions, and this will show the number of CFU per milliliter of water. This table shows the number of CFU which indicate negligible, moderate, and heavy levels of contamination. These limits are those published in the IATA guidance material on microbiological contamination in aircraft fuel tanks, but they are for guidance only. Users can always choose to set their own contamination limits based on their experience. The Micromonitor 2 test is very flexible in that respect. Here we see the examination of tests of fuel samples over 4 days of incubation. If a fuel sample is tested, there will generally be far fewer microorganisms present than in water samples. In fact, for clean fuel, you will typically get a clear test with no colonies, or maybe just 1 colony. Again, heavy contamination may be detected after only a day or 2, at which point further incubation can be stopped. Otherwise, continue to incubate the test for up to 4 days, at which point the final result can be read. When testing fuel, it is normally possible to count the number of colonies present. So the number of CFU per litre can be calculated. This is the number of colonies counted times 2000. Note, convention has always dictated that whereas for water, contamination is expressed as CFU per milliliter, for fuel samples, contamination is generally expressed as number of CFU per litre. Make sure you know how the results are expressed when reading test reports. Here are the contamination limits for CFU in fuel samples taken from the IATA guidance material. These limit values are generally appropriate for fuel samples from aircraft fuel tank drains. For samples taken from the fuel supply chain upstream of the interplane fueling operation, less stringent limit values may be appropriate. Some recommended contamination limits for aviation fuel supply can be found in the JIG Technical Information document on microbial monitoring strategies, which is available from JIG online. It is important to appreciate that even heavy contamination doesn't necessarily mean that the fuel is unfit for use, nor does it mean that there is already severe visible microbial growth in the fuel tank. It is merely an indication that contamination is above normal, that microbial growth is likely to be occurring, and unless something is done to prevent it, the situation will get worse. You have plenty of time to act. The first action will usually be to check by testing a fresh sample, but not acting could result in serious operational problems. Also, there is not always a precise correlation between fuel phase and water phase contamination. If you test both phases, we would generally recommend acting on the test which indicates the highest category of contamination. So in summary, using Micromonitor 2 tests and counting or estimating the number of colonies is a simple process without the need for any specialist equipment. The test provides a clear visual indication of the severity of contamination. Remember, it is the number of spots, not their size, which is important. Remember, contamination limits are for guidance only. The Micromonitor 2 test is flexible enough to adjust these to your particular experience and requirements. I hope this training session has been useful. More technical guidance and answers to frequently asked questions can be downloaded from our website, www.echamicrobiology.com. I'm happy to take questions now, and we are always available to help you further. Thank you.